Hello, everyone. Welcome to today's webinar. And today we'll be going over the borehole data management using RSLog. And majority of the presentation will be hosted by Alireza. But first, I'll be starting off with introduction to rock science software. So my name is Steve, and I'm a main developer working for RSFile and Saddle3 program. And Alireza is a senior manager at Rock Science and has been with RSLog since its inception. Prior to joining Rock Science, Alireza has been working as a senior geotechnical engineer, leading several major civil, infrastructure, residential, and commercial development projects. His experience involves site characterization, pile design, seismic assessment, and ground improvement for over 20 years. RockScience is a world leader in developing and innovative 2D, 3D software for civil, mining, and geotechnical engineers. We're dedicated for delivering industry-leading software programs, exceptional customer service, and unparalleled technical expertise that engineers can rely on. From a team of 25 years ago, we've grown to a team of 80 with 4 offices and representatives across the globe, working hard to build geotechnical tools used by over 10,000 users now. So this is just map of all the resellers we have in the world. Some of the programs that we have for slope stability include Slide 2, Slide 3, R2, R3, Rockwall, Rockwall 3, S-Wedge, Dips, and so forth, RS data. And we have many other programs that we specialize in excavation design, including RS2, RS3, EX3, Unwedge, RS data, and so forth. And also we specialize in settlement and foundation design as well for analysis, including FEM analysis for using RS2, RS3, settle, RSFile, RS data, dips, and RSLog. And this is our just overall map of integration that can be used with the other programs. So in case if you have Slide 2 model and you have Slide 3 model, those two programs can be integrated together, and RS3, RS2. And as you can see, RSLog is also integratable with Slide 2, Saddle 3, and other programs as well. So now I'm going to pass on my presentation to Alireza.
And welcome everyone. Yeah, so today I'll be presenting this webinar introducing RSLog and its features. So what we will do today, we will talk about borehole data management first, and then we are going to have an overview of major features of RSLog. We have very exciting news and updates to share with you. And then we switch to live demo. And at the end, we come back to answer your questions. Okay, so let's first talk about what type of data you need to deal with, you need to collect as a geotechnical or environmental consultant. Obviously, borehole data, that's the basic data that you always collect. This data could be your SVT data, other field test results, soil layers, groundwater level, and so on. And then you also have some photos taken during site investigation. So it could be your core photos, or it could be, let's say, if you're doing a type of site reconnaissance type of projects, slope reconnaissance, it might be a combination of hand doggers and photos. So that's another step. And then lab testing obviously generates another large data set, different types of testing depending on complexity of the project. Groundwater monitoring, you go back, measure water level. Again, in a lot of companies, this data, like every single of these data sets, are saved in different files or folders, a bunch of photos, and so on. And then you prepare borehole log based on all of this data, and based on the borehole logs and stick logs, you want to go with subsurface visualization, designing the cross section, and in the course of the project, you will need to have access to geology maps, and when after a few years you have several projects, you would like to have the GIS map. So these are essentially the basic needs of a consulting firm that deals with different types of geotechnical or environmental projects. Now, so you need a software. Obviously, the most efficient way to take care of all this data is to have a software that manages all this data. So as you saw in the list, borehole logging was only one of those features. But the software that you choose should have all the technical features that you see in the previous slide: borehole logging and GIS and other types of reporting. That's the basic needs. And then flexible licensing, that becomes very important. You don't want to use a software that, let's say, uses a dongle key. So these are all limitations. You prefer a more flexible type of licensing, not only, the license that only attaches to one computer and can't be used by others, or if the computer is broken and now you don't have access to your software and your license is essentially gone. Another criteria is output quality. Obviously, you want something presentable. The report should be good looking. Team collaboration. In a lot of large projects, what you need is to work, like several engineers may be working on the same project. Some in the field are entering data, and some other engineers may be reviewing the data and finalizing the reports. So you want a software that multiple users could work on the same project at the same time. Cost is another key feature. If your borehole data management software costs you tens of thousands of dollars a year, then that's not affordable for most companies. And then global access. All of us experienced during pandemic that there was a limitation on how many engineers could be showing up in the office. So a lot of us had to work from home. And the issue that we had to deal with was that the software was not, you could not run the software from home because you needed the dongle key, or you needed to be in the office so you can connect to the local server and run the program in terms of licensing limitations. So it's important to have global access, even if you go on vacation or traveling and you need to review something, you need to check something or help someone, one of your colleagues with something. Global access becomes very important. Now, what works hand in hand with key features of the software is the software company that you choose. You obviously want the software developer to be familiar with the whole process of data location and different types of report that you generate. A software is only usable if it meets the requirements and the way that you do the project, right? And in that regard, at Rock Science, geotechnical engineering is what we do. It's our expertise. And many of my colleagues have years of consulting experience. Reliability is another key criteria, because by purchasing a software, you're making a long-term investment. It's not just doing this project and done. No, all of your projects over the years will be handled by this program. Your data will be there. And last thing you want is that a software that you purchased 10 years ago and you're heavily dependent on, it goes out of market. Clarity on cost is another important. You need a clear cost structure. You want to know exactly how much the program costs, and you don't want to get surprised with an unexpected invoice. A responsive tech support. When you need help, you send a support request, and it takes say 2 weeks to get back to you with just some communication without any practical solution, then at that point you're already in trouble with your client and with your manager. At Right Science, we understand that our users are real engineers working on real projects, and real projects have deadlines. It's important to come up with at least an intermediate solution so you can wrap up your project. I believe one of the most efficient ways to improve a program is to have an open line of communication with users. Nothing is too small or too difficult to do or to add to the program. At Rock Science, we carefully listen to our users and determine future roadmap of RSLog based on that. If you compare RSLog 6 months ago with all the features that we have today, you will be surprised. And this is all based on our communications with you. Ongoing development is in line with what I just said. Users need improvements and new features. And we have a dedicated team of developers. And typically every 3 to 6 weeks, you will see an update in RSLog with a bunch of performance improvements and new features. So all of these 6 criteria are the top priority of Rock Science. And we are known to have an excellent support when you need us. So we are always on your side. Okay, so let's talk about how RSLog can help you to take care of your borehole data. So as we said, this like the borehole data starts with site investigation. You collect a lot of data, and then there's photos. You take some photos. You do some instrumentation. The instrumentation could be as simple as a piezometer in a borehole, or even a more complex type of instrumentation. Lab tests is important. When you do the lab test, you want to bring some of the test results into the borehole log. And then you generate the borehole log. Once the borehole logs are reviewed and approved, you generate your subsurface model based on the borehole data. With your subsurface model, you need flexibility in terms of how to design the cross section, how to connect the layers, how to define the lenses, what are the what are the field tests. You see in this example the SPT blow counts, for example, beside each borehole. So all of these steps that you see here in this cycle during different phases of the project, these are all taken care of by RSLog. Over time, you will have a large number of projects to deal with. So with RSLog, you can see all of your projects on the same map. And let's say if you have a proposal and you want to know how many previous projects you have in a certain geographic area, you can easily just zoom in and see your previous data and come up with an optimized field investigation for the new project. Instead of 20 boreholes, you may go with 10 boreholes. And that's an advantage over your competition. Data exchange. So obviously, during the course of data entry, you may need some interaction with other programs to, let's say, to do the slope stability or liquefaction or bearing capacity analysis. With RSLog, you can import data from CSV or Excel. You can even import your existing GIS files if you want to import some of the boreholes or data from, or you want to see, what's inside one of the old projects and generate the borehole logs here with RSLog. The same thing with DX. We have a basic version of AGS importer. And then in terms of export, you can export all of your data to Excel. You can export data to Google Earth formats, KMZ files. So there's a lot of flexibility in terms of communication with other programs in RSLog. Okay, So now let's talk about our vision for RSLog. So the way we looked at RSLog when we started designing it is that the core of RSLog is made of the borehole data. So borehole data is essentially the building block of RSLog. Your borehole data includes the coordinates, either UTM or geographic coordinate. It includes the soil layers, it includes the field test and lab test, and these are everything you need in order to do your different types of analysis in your projects. With RSLog, you can generate different types of reports based on this core database of your borehole data. The simplest one, the most basic one is the borehole log, right? So you can design your own log template the way that you want, the way that is more consistent with your company's template style. And then you can generate report figures. Part of any geotechnical report or environmental report is your project location map and borehole location map. So these are all automatically generated by RSLog. Organizing photos. So once you upload photos, you can generate a photo report. You can assign a title or caption to every photo, and then you select photos, and you can put 4 photos on a page or 8 photos on a page, depending on how you want to build your photo report. The cross-section design is another feature or another type of report generated by RSLog. We'll talk about it later in more detail. A 3D visualization based on the cross-section design, and then what you can do, you can create a 3D model of your site, see all the boreholes and all the cross-sections that you designed in that project, and more, and then you can export the model to different 3D graphic formats. GIS Map, we talked about it. It's a built-in feature in RSLog. RSLog is a web application, and maps are an important part of RSLog on pretty much every page. Now, in addition to these existing features and report types, the way that RSLog is designed is that we can expand these features. We can add more modules or more features in the future. For example, engineering analysis, like simple type of engineering analysis, is something that we can add in the future. You have your SPT data, why not correlating it to, say, undrained shear strengths or friction angle or relative density, or something that you need to use it in another engineering analysis, like liquefaction, for example. So that's another thing. And once you have the data, we can do some statistical analysis, let's say, to estimate let's say, different soil properties across the site, not only at the borehole location, but you want to estimate them at other locations, utilizing machine learning, for example, to come up with some additional data and estimates. Now, going over major features of RSLog, the first thing to mention is the easy setup. There is not a lot of setup because you don't need any installation. RSLog is a completely cloud-based web application, so the only thing you need is to just log in and use the program. No dongle key, no license file. You can use it on this computer now, and then just go to another computer. 2 hours later, you go home, use your personal computer to just log into RSLog website, and you will have access to your data. So that eliminates a lot of headache for you and for your IT team, because the setup is essentially eliminated. You can access your data at any time from any smart device. As long as you have internet connection, you can just log in and see your data. In terms of data entry methods, if you are connected to internet, then that's easy. You just use the user interface of RSLog and enter data. You can import from CSV if some of your data, let's say SVT bureau accounts, are in an Excel file. You can, instead of re-entering manually, you can just import from CSV, or if you have Kint and Dix files, you can import. If you're not connected to internet, let's say if you are on a remote site with no internet connection, no problem. There are two options for offline data entry. One is RSLog Excel templates. So RSLog has its own Excel templates that you can use. You just download the template. There is one separate file for the borehole, one separate file for project. You enter the data, and then once you're back connected to internet, from within RSLog, you will upload these Excel templates, and a new project will be created. Another way to do the offline data entry is our RSLog offline app. It's a Windows-based application that you can install on your laptop, and it has an identical user interface with RSLog. It's very easy to use. You run it, you enter the data, and once you're connected to internet, you just go to the offload menu, and with the offload menu, you will send all the data automatically to your RSLog account. So in less than 10 seconds, a new project will be created in RSLog. So the beauty of this is, while you are on site doing the data entry, once you push the data to the server, then your colleagues sitting in the office, they can just refresh the page and see a new project. They can have access to the borehole data, review it, and generate the rest of the reports. In terms of borehole data entry, because we are dealing with a lot of boreholes, a lot of data, we broke it into different sections. But generally speaking, borehole name, depth, groundwater level, sample list of layers, pixometer, and so on. These are basic part of borehole data. With lab tests, RSLog doesn't process lab tests, but obviously lab test results are an important part of your borehole data. So what you can do here, you can put all the results of your lab tests in an Excel file, and then you can easily import them here into RSLog, so that later you can display them in the borehole log. Just change your template, add moisture content, for example, as a separate column, or you want to show a plot of other limits, for example. You can easily do that. We've broken lab tests into different tabs, different groups of index tests, strength tests, chemical tests, but again, there is more flexibility here. So if there is a lab test that you don't see in the default list of lab tests in RSLog, very easy, you go to user defined tab, and on user defined tab, you can add your own lab test, and user defined lab tests can also be displayed on the borehole log. Cross-section designer, the idea is that we have the borehole locations, we have the borehole soil layers or rock layers. User chooses to, chooses the boreholes that want to participate in the cross-section, and when a new cross-section is created, it's essentially an empty cross-section, just the boreholes, like the stick logs of the boreholes. And what this module is, the cross-section designer, is just a simple tool to help you draw lines, groundwater level, add text, add polygons. Essentially, polygons are your layers. You can connect layers together the way you want. You can define lenses the way you want. And then after designing it for each polygon, then you can assign a certain hash pattern to that polygon. And in terms of hash patterns, we have all USCS hash patterns, over 35 of them. We have over 150 different AGS hash patterns, over 35 again types of rock, and some miscellaneous hash patterns such as grout and concrete and bentonite and so on. So once you design this cross section here, then you can export it to DXF. You can export it to Google Earth. So that includes all the boreholes, but also the 3D or the actual cross section that you design will be also overlaid on Google Earth. Another feature in cross-section design is site visualization. So you can see all boreholes of the project and all the cross-sections of that project all at the same location. There's no limitation on how many cross-sections you want to define for the project. It's interactive. You can rotate, you can zoom in, zoom out. You can even add the terrain model you see here in the background. So this terrain model is automatically downloaded from different map servers, and it's generated based on LiDAR data. So you don't need to upload anything. It's an easy and free feature in RSLog. Figures. The basic type of figures that we generate for every geotechnical report is a borehole location map, such as the one that you see here, and project location map. Let's say even cross-section figure. So all of these are automatically generated in RSLog. The only thing you need to do is to just zoom in to the view that you are happy with and select a figure template. So for example, here you see that this template only has footer. There's no header here at the top. This is up to you. So you can design your own template in RSLog. We have a lot of flexibility, a lot of simple tools to use. So it's not like some other programs that it needs an IT person to be able to change the templates. You can easily change and create your own template. So GIS Map, it shows the location of all your projects that you have in RSLog. In this example, you see RSLog projects are shown in red. And now what we did in mid-2022, we added a feature to show your previous projects. We call them external projects, and you see them here in with green markers. So the idea is, yes, you have a number of RSLog projects, and it's nice to see them all on one map. But how about your previous projects? If your company in the past 10 years, if you have done like 500 projects, why not bringing all of those projects, at least the project locations? So at this point, we are talking about bringing only borehole locations, project locations, previous project location, so that you have a comprehensive GIS map that can help you with your proposals when you are pricing a new project. You know how much data you have in different areas. So this is done, and at no cost, you can easily, as long as you have a list of all your previous projects in Excel with project title, client name, site address is not necessary, but you need to have latitude, longitude for the project location. And you can import this data into RSLog in less than 10 seconds. We've tested it with over 1,000 external projects, and the map loads very easily, very fast. So this is a very interesting feature for a lot of companies. I myself, the company I used to work before joining Drive Science, we had 4,000 projects to put on the map, and there was no RSLog at that time. So I realized how much effort it needs to do that. Most engineers do it in Google Earth or other ways, even create their own GIS system. Now, the other thing that we are working on to add to this GIS map is to make it true GIS feature by, for example, letting you to add different layers to the GIS map, be able to load KML files. We've successfully added geology maps. So if you are in the Canada, US, Australia, UK, and New Zealand, so the geology map has been added. It's not yet deployed to the website. You would probably see it towards the end of May with a bunch of other updates that we are working on. Okay, so log template design is obviously, I would say, the heart of the program. You need an easy log template design. You need something that is user-friendly, so you can easily change like the paper size and margins and fonts and choose the log columns that you want to bring into your Borehole Log. RSLog has a very user-friendly log template designer. It's a general template designer, including Borehole Log template design. For example, for the design of header and footer of your templates, it's extremely easy. You just use the toolbar to add different elements essentially to your header and footer. It could be a static text. It could be a database label, and database label is bringing borehole data or project data into your Borehole Log, and then change the font size and colors and everything. Like an example here is you see that this field here is showing borehole description. So these are essentially borehole, the nodes that you want to assign to a borehole, and you want to show it in the header, or B name being borehole name. So when you generate the Borehole Log, that will be populated with the borehole name. Very easy to use. Everyone can work with this template designer. Another important flexibility that we brought into RSLog is customization of different lists. And these are the lists of, for example, sample types. So when you set up your RSLog account, it comes with a list of like default sample types, default build test, and default drilling methods, for example, and so on. But all of these lists are customizable. You see here, this is a screenshot of the settings page in RSLog. In Field Investigation tab, if you go to the Sampling and Boring tab, you see the list of all sample types here, and you can easily add your own sample type and even add an icon or a symbol for presentation in the Borehole Log. Or you can change the moisture descriptors, the way you want, because in RSLog you can define sample moisture. In terms of import export, this is an example of import from CSV. You can filter what records you want to import. In this example, you see we have data for different boreholes, and you want to only import the data for AH20-1, so you can filter the data, and then you can map the columns. There is no need for following a sequence of the columns the way that you see them in tables in RSLog. Most of them will be automatically mapped, but you're still able to change the mapping. So very easy CSV import feature. If you have GINT files and you want to import your GINT files into RSLog, we have a tool for this. You just load your GINT file and similar to correspondence files with GINT, you can here map the data structure of your GINT to RSLog. A lot of these fields will be set automatically. These are based on our experience with different hint files. But if you want, you have full flexibility to customize these and set the right database field and tables and just import the data. Most of your hint data will be easily imported into RSLog. Import from Excel is another feature. We talked about it. You can do offline data entry and then just import data here. Export to Google Earth. We talked about this. From cross-section designer, you can export to Google Earth, and this is an example. You see even the cross-section itself is completely exported as a 3D feature here, overlaying on top of Google Earth, and you see all the boreholes with their different soil layering at their real location. Exporting your entire data. So if you want to get a backup of all your RSLog data, you can do it easily. You can export. You can select the project, and you can easily export the entire project data into Excel file. And these are our RSLog Excel templates, so they are very easy to follow. And if you're looking for example, list of samples in this borehole, you just go to the samples worksheet in that Excel file, and you have all the data in there. If you want, you can also export it to JSON file. JSON is a format, and it's an advanced kind of format relative to CSV and XML formats for saving data objects consisting of attribute and value pairs, and even arrays. You can easily add it. A lot of programmers are familiar with this. So if you have a programmer in your company who wants to read the data and process them for further reporting and processing, you can export to JSON file. The beauty of this is that all data of the entire boreholes will be exported to one JSON file. So all of your data is there, and then you can even import JSON file into Excel or any other database management software. In terms of integration with other programs, with rock science programs, we've successfully integrated RSLog with Settle3, and with the slide 2, Settle3 is our flagship settlement and stress analysis program. If you're not familiar with it, I absolutely recommend that you go download the program. It's very easy to use, and it has a lot of features. So with Settle3, you can directly import borehole data and their locations into your Settle3 model, and that will save a lot of time. With the slide 2, which is our slope stability program, I'm sure a lot of you are familiar with it. If you design the cross-section in RSLog, then you can easily read that cross-section geometry from within slide 2. So that's a huge time saver. You don't need to redo it, recreate the slope model in a slide 2. And we are going to integrate RSLog with more rock science programs. This is something that is in our roadmap, absolutely. We've integrated RSLog with GeoSeta. GeoSeta is a nonprofit company in the US. They've collected over 60,000 public boreholes in the US, and you have a map in GeoSeta that you can zoom in and click on a borehole. We partnered with them, and GeoSeta is now using RSLog engine to generate borehole logs based on that data. Some of this data are in GINT, some of the data are in VX format. So it was important to be able to show them in a presentable manner, and that's what the integration does. If you use Data Nest app for data collection, for borehole data collection, you can just after data entry in Data Nest, you can export it to Excel and then you can import those Excel files, which are RSLog Excel templates. You can import them into RSLog. So it's a two-step process, but in the near future, we are going to have API integrations. So the integration is going to be more smooth and easy. Okay, so I'm going to switch to live demo now. But before that, I recommend that you start your trial of RSLog today. Just go to Rock Science website and go to RSLog page. There's a free trial button that gives you 2 weeks of trial for RSLog. If you want to extend that trial, no problem. Please let me know or contact support, and we'll be more than happy to extend it for you. If you have also any other question, contact support, and they'll probably forward it to me. I'll be more than happy to set up a meeting with you and answer any questions. Okay, so here is the environment of RSLog. You see here, like the dashboard page gives you some general information about your license and the last project that you've used. Access to different features in RSLog are provided from this left navigation bar, left menu panel. There's some account information like your company logo or licensing that you can set in the company account page. I just skipped some of the pages. I just go to the most important ones to show you the major features. But in terms of user management, we have a role-based user management. So the way it works, when you purchase your RSLog license, you choose how many users or how many seats you want with that license. Let's say if you have, if you want to have 5 users, then what that means is that you can have 5 concurrent users logging into RSLog and using the program. The license or the users are not tied to a specific computer or device. So that's the beauty of a web application. You can share the users. Let's go to the projects page. So here you see the list of projects in this RSLog account. At the project level, we collect project title, client, which you can select from the list of your contacts, which has its own separate page. Project number, unit system, coordinate systems. So all of these will be defined at the project level. Now, with the site location, if you have an address, you just enter the address, or you can just click on the map, and here you have an interactive map to say that, okay, my project location is here, and you can even draw a polygon or polyline for linear projects. You can draw the polygon to show the site area. Now, I switched to the list of boreholes for this project. This project, you see, it has 4 boreholes. What I want to add at the project level, so on projects list, you can assign projects to certain users. So there is a lot of flexibility in terms of in what each user can do. So you can define roles, you can define access levels, you can limit the access of some of your users to certain projects only, or even to certain pages. So, for example, if you design a report template, you want to make sure that no one will mess with that report template, accidentally deleting it or changing something in the report template. So you can hide it from all users, and only the admin of your RSLog account will have access to things like report templates. So you can define all of that, including project assignment. Here you see list of boreholes. You can duplicate or copy a borehole And this is good, especially for the type of projects that you have a uniform geology across the site. So you can copy a borehole and then just change some of the layer thicknesses and so on. Now for the borehole, because we are dealing with a lot of data, we've broken it into different tabs. You see list of samples, list of field tests. Field tests could have different columns. In this example, you see with SPT, we have an N60 that is probably what you want to report, or you want to report a more detailed kind of data, like every single blue counts for every 6 inch, depending on what you enter here. These are all defined and customized in RSLog. Wherever you see this icon, it will take you to the settings page, and you can define, let's say, list of the field tests. And even for each field test, you can define how many columns of data that field test is going to have in your data entry page. So CPT, for example, we have QC, FS, U2 as the output columns. If it's a vein shear test, you may want to add 2 for residual and peak. So it's completely up to you how you want to define them. In terms of a stratigraphy, what we have here, let me edit one of these layers. So you can define both soil and rock layers. You can give it a layer title, top depths, bottom depths, and then assign a hash. Again, this hash pattern, we have a huge collection of hash patterns in the program. Layer description, you can enter the way you want. You can add black lines and adjust it the way you want to be displayed in the borehole log. Even here, we help you, showing you a list of your field tests. So see here, I go to SPT test and I see all of my SPT test results, or I can click on lab test. It gives me whatever lab test or field test I have within this layer. So remember, this is from 6 to 18 feet. So these are just test results within this layer. That helps you to finalize your field description of the layer. If the field description is saying that this material is dry, and you see moisture content of between 8.6 to 13.6%, then okay, most likely this is not dry. You want to modify the layer description, or maybe break it into sub layers, right? Depending on the consistency or moisture changes with depths. Same thing with drill run. So if you have if you do coring or drilling into rock, you can add drill runs. There are a lot of parameters that you can define for each drill run, different weathering level. So these levels, for example, for the strength level or weathering level, these are all coming from the settings page. These are default RSLog values, but you can obviously edit them and add your own broad classifications, essentially. Same thing for discontinuity. I don't go into the detail, but with instrumentation, piezometer is something that we install in many of our boreholes. You can easily define different types of piezometer and plug type, and add different pipe segments, the type of backfills. We have different types of backfills: sand, bentonite, drill cutting, and so on, that you can assign. And then parameter monitoring in that piezometer over time, you come back. So as you see in our first slideshow, we showed you different types of data collected during the course of project. Now we have all of them here. That's the beauty of RSLog. All of your data will be in the same place, and you can bring everything into your borehole log. So you see there is a preview button on the right side of the page that will generate your borehole log. This is an example of the borehole log generated by RSLog. You just need to select the log template that you want to use, and then the log based on the log template. Your borehole log will be generated. You see that the hash patterns could be in color, could be in black and white. It's up to you. You see the piezometer here. This is a PDF viewer. So you already created a PDF, right? This is just a PDF viewer. You can easily download it from here and include it in your geotechnical report. This is an example of the project location map for the same project. Again, it's a PDF viewer. This is cross-section report. So a simple cross-section, we just put it in the PDF report. I just quickly go to the lab tests. So the lab test page, as we said before, the idea is that you can easily import the lab test results. You see this toolbar at the top of all tables in RSLog. You can, in almost all of them, you can import data from CSV or export to CSV and Excel. These are some of the test results. You select the borehole, you select the sample, and then just enter data. This is on user-defined tab, so you're not limited to the tests that we've put here by default. These are the most common type of tests, but you can expand that list. With cross-section designer, it's very easy. Again, you don't need AutoCAD to generate a cross-section. So what you need, you just connect the boreholes together, and it will generate this empty cross-section, a blank kind of cross-section that shows only the borehole locations and their layers. You see that in this example, we have the SPT data also. This is DCPT, dynamic cone penetration test, shown, which you can turn them off. You can just focus on the boreholes. You can change the settings of the legend. You can, as you see here, these polygons are drawn the way that user wants. They don't need to be just a rectangle, connecting layers together. Sometimes there's no corresponding layer, and you want to define a lens. So these are very easy in RSLog. You can change pattern types, different types of hatch patterns here, and then you can switch to 3D. And in 3D, what happens is you will see all the boreholes. You see this borehole is designed as, or the data entry is meant to show it as an inclined borehole. If you have any other cross section, then you can see that cross section, all other cross sections also here in 3D. So what I can do here, I can show you a more sophisticated example here. You see in this example, we've added a polygon, and we marked it as contaminated zone. We gave it some transparency to essentially sit on top of the other layers. We can add question marks to so these are all the things that, like, I've seen some geologists or geotechnical engineers are interested when they design their cross section. Now in 3D, in this example, we have a lot of boreholes, and as you see, like over 40 different boreholes and different cross sections. You see another cross section here in the back. Now, if I want to turn on the terrain model, it's easy. You see the terrain model is now added. I've added some vertical exaggeration, so this terrain and the borehole elevations are exaggerated just for presentation purposes. But you see here, let me turn off the guide labels. It will be easier. Yeah. So you can give some transparency to the terrain model. You can turn it to satellite view, and you can move it up and down, to exactly match to your boreholes. So all of these are available in RSLog as built-in feature. These entirely in a web application. You don't need to download anything. You don't need to learn how to use. It's very easy to use. These are other features such as figures and like GIS Map. But let me show you the report template very quick. We are almost out of time. I have another 2 minutes. So here's one of the log templates, and as we said, it's very easy. You can here change the paper size and margins and fonts for different sections of the template. You can change the header and footer. You see here I can zoom in, and you see different types of either static labels or database labels. You can change the way you want them to show. You can add your own logo here, resize the logo. You can even, if you change your mind, you don't want project address in the header, you can just drag it, bring it into the footer, change its size, and there you go. And that's your log template. In terms of what you want to present in the body of the log template, which is the log columns. Here's an example. You have different log columns. You can easily change the sequence. Let's say I want to move the hatch column to after description. This is done and saved. And in terms of properties or settings for each log column, we have different types of log columns that you can choose from. And as soon as you choose any of them, there will be some additional setting for each of them. For example, for samples log column, do you want to show sample number? Do you want to show sample type? And if sample type, you want to show a symbol, or you want to show an icon, and a symbol being acronym of the sample type, where you define it in the settings page. So there are a lot of flexibilities with RSLog. We let you present your data the way that you want and the way that is consistent with your company style.